So now just continue the discussion further of RC circuits, which is very well part of our syllabi and quite simple in generating differential equations. First order RC circuit we discussed, we generate differential equation, and since it was simple type we got the answer also. So now any circuit, see, if only resistive circuits are there, that is a very trivial problem. Multiple voltage sources and resistances, it is a very simple problem, not worth to be discussed in the class. The videos will be given to you and you can very easily work. But whenever capacitor comes into picture, there is a differential relationship between voltage and current. Because of that, it makes the circuit somewhat complex. And multiple capacitor. And now there is one more element for which there is no water level analogy equivalent, that is inductor. To that we shall come later, but at least we must get a very good expertise on dealing all the circuits with resistor, voltage source and capacitor. For resistor we know V equal to IR, or to be very precise and classical, Vt equal to R into It, because we can say that voltage can change with time and resistance remains constant with time. We don't, remember each and every statement what I say also needs to be verified. To be very precise, resistor doesn't remain constant with time actually. If current flows for quite long time, resistance get heated up and resistance also changes, but those things we are ignoring. Same thing may happen with the capacitor because of aging, but that is we are ignoring. So in our discussion, unless otherwise explicitly specified, the terms R and C are constant, therefore we don't say R comma R bracket T and C bracket T. R bracket T it is assumed to be constant, and in this case it is values are chosen very simple values so that calculation should become easier. Those are chosen 1, right? So now I will redraw it to small and we can proceed further. So we now presume the switch is closed, so or we can show the switch and it is closed. So Kirchhoff's laws, you know, you have studied that at any node, algebraic sum of currents equal to 0, that is a classical definition, but working definition at any node, what is working definition? At any nodes, currents incoming equal to currents outgoing, we assume one direction, and if the answer becomes negative, it is actually the reverse direction, right? Okay. So this is now a common terminal ground. We say this is 1 volt. Common means with respect to this, we measure all the voltages. This is a common terminal. We also call it ground. With respect to this, we measure all voltages. So sometimes it is said like this also. Then 1, 1, 1, 1. This is VOT. And this is VE. Now, we first develop, VAT will come and it will be removed later. So, what we should do, whether this is simple or this is simple, this one, no, this is not simple, because the circuit which we dealt with means single circuit, we dealt with a single RC circuit, right? Input, output, input 1 or V and output. This is not the same circuit, it is branching out. But if you look at the second circuit is simple, because this is VAT, right? So we work on the second circuit first. So here what we are having, listen very careful now, note down, and I think everyone will understand everything. So for this for each resistor now, what we will first mark, voltage we have marked, this is 1, right? 1, VAT, VOT, common. Now we mark currents, So this being the second loop, we mark it as I2T, right? I2T, and now choosing how we choose currents, means you can choose when there is a system, you can choose some and you can use Kirchhoff's law to with at one node your 3 branches are coming, 2 you can choose, and third you can consider to be this plus this equal to 0. But which you choose, that is a wise decision. Means that comes through experience. Classically, anything you can choose, you will be getting the answer in any case, but you will be getting the answer easier if you choose wisely. So that wisdom comes through the experience. So how AI boards will get that is a very interesting point for you to note down. Now here what I will choose, I will choose this as I1T. You can choose any. This is 1. This I write 1. So what I say, this as I2T, and I choose this as I1T. I have not chosen this as I1T. I chose this as I1T, right? This is I2T. So what is this now? What this would be? I have chosen directions also properly. So this would be. Now I will not write I3T. If I write I3T, then again I have to substitute. So I will directly compute I3T using Kirchhoff's law. What is that? I have chosen I2T and I1T wisely. So this should be very easy. What is this? Now, what is this? I-T plus I2, right? Both currents at this node are outgoing. This is incoming, right? So current incoming equal to current outgoing. Current outgoing are I1T plus I2T. So this is I1T plus I2T. Is it right now? Now, so what I have done in my circuit, this is a very extremely simple, I am telling, no complexity at all. There cannot be any simpler expression than this. In this circuit I have got one node, and how many loops are there? One node, and how many loops are there? 3 loops. I can choose any 2 as I wish. One node I have used. Now one node will not lead to any equation. Why? Because that the nodal equation I have used instantly to define the current. लक्षात लगा? Kirchhoff's law, Kirchhoff's node law, Kirchhoff's circuit law, तो जो बिल अप्लाय करणार आहे तो नवीन इक्वेशन मला देणार नाही का, तर तो अप्लाय करूनच मी याच्यातला करंट काढलेला आहे. आता ह्यातला करंट किती आहे? हा I2T. इट्स अ सिरीज सर्किट, नथिंग इज कमिंग आउट, सो दिस इज आल्सो I2T. आता from this resistance current is I1T plus I2T, from this resistance current is I2T, or this capacitor I1T, or this capacitor I2T, right? So both resistances currents I know, both capacitances currents I know the relationship between voltage and current for a resistor, I know relationship between voltage and current for a capacitor. So I can choose, write down 4 equations. काय अडचण आहे? Right? And voltage at all points I know, because how many points are there in the circuit now? 1, 2, 3, and this is common 4. So with respect to this, I know this, I know this, I know this. So voltage across this I know, voltage across this I know, voltage across this I know, voltage across this I know. So for all 4 components I know voltage and current, so I write the equation. So I write for this first. So what is this? I2T is the current through capacitor. So this must be equal to C into voltage across, C into differential of voltage across the capacitor. Here C is 1. And what is voltage across the capacitor? That is VOT. So whether everybody of you agrees to this, I2T is equal to dVOT by dt. Because VO is VC and C is 1. Two governing laws, ICT is equal to C dVCT by dt for any capacitor, and for any resistor it need not be said, but we say IRT is equal to VRT upon R. Is it right? Is it okay? Now for this resistor, what we can write? For this resistor, I2T is equal to voltage upon the resistance. I2T relation is this. So I have to measure voltage this minus this. And resistance is 1. Resistance is 1. So it is VAT minus VO. This is equation 1. This is equation 2. Now for this what I can have? I1T plus I2T. This current. I1, here we go back capacitor. So I1T ka in, what is I1T? I1T is equal to C D V VC is VA. So C is 1. So it is D VAT by D. And I1T plus I2T is equal to 1 minus VA. Because resistance is 1. So using this 4, you should be able to derive the further equation. How we proceed? So I think now there is no need to look at the diagram. We can derive here itself. So which you will use? So you will first get rid of I2T if you want. So can I equate these two? So dVOT by dt is equal to VAT minus VOT. So can I write using 1 and 2? Can I say like this? dVOT by dt is equal to this plus this. Alternatively, taking this on the left hand side. I hope that now there is no need for repeating the step. Plus VOT is equal to VAT. This is what we got, right? But what is my target? I should get the equation in terms of VOT, its differentials and constant. So VAT I should get rid of. So how can I get rid of VAT? I can get rid of VAT means for that I should use VAT which is here and here. So how I can eliminate that now? Which equation? Why should I differentiate right now? So you tell me. So now we are moving. Now we moved straight forward to this, but here there is some jumbling situation in the sense that exactly what I should choose now. We need to work. So what should be done now? So only VAT means somehow for VAT I should get, so this I can say that equation 5 is obtained by using 1 and 2, but still 3 and 4 are not used. So by using 3 and 4, so here what I did, here I got, actually I2T also I don't want. I got expression for I2T for capacitor. I got expression for I2T for resistor. And then I equated them and I got rid of I2T. So using these two now, you got this. Now using these two, you again get the expression for VAT. VAT means what is this? VAT as determined by the second loop. Now you determine VAT by the first loop and equate them. So how I can do that? So I2T is okay for me, because why I say I2T is okay? Because I immediately know the relationship of I2T having with VOT. So I will think now, can I work on this equation more? So that is through experience you should gain. I want to work on equation 4. In equation 4, what I get in equation 4? I get VAT. VAT is there. So I will try. What is VAT? VAT is equal to 1 minus I1t minus I2t. Right? Just by some trial and error, VAT is 1 minus I1t minus I2t. For I2t I don't have any problem because I immediately replace it. Right? So for I2t what I will do? I will immediately replace by dVOT by dt. For I1t what I have? dVA1t by dt.
Yes, we will differentiate equation 5.
So what I will do? So this I can say equation 6. Equation 5 contains VOT, its differentials and VAT. Equation 6 contains VAT, its differential and differential of VOT. So now what we do, you know what is VAT. You can put it on this side, but still dVAT by dt remains. So what will you do? Differentiate 5. So by differentiating 5 what we get?
dVAT by dt.
dVAT by dt is equal to d2 VOT upon dt square plus dVOT by dt. This I can see equation 7. Equation 7. So equation 7 I got. Equation 6 I have got. So again, is it that when you come across solving such complex equations, there is a risk of looping? What looping? No. From one equation you start deriving something, go further, and again it results to same equation. So here you wanted to get rid of VAT, that you can put here, but still VAT is here. So now you just see how we break the deadlock, how we come out of this. So equation 5, equation 6, equation 7. So what will you do? So what will you do now? So you will use equation 5 and equation 6. What VAT is this, VAT is this. So can I write its RHS is VAT, its LHS is VAT. So these two are equal. Agreed? So can I write dVOT by dt plus VOT is equal to 1 minus dVAT by dt minus dVOT by dt. Is it agreed? It is using 5 and 6. Using 5 and 6. Is it okay? Now, in this expression, only this term is okay for me. This term is alright. This term is alright. This is what I don't want. So for that, I have got so this I can say 5 and 6 give this, and using 7 I put this. So what I get? So before putting it, this dVOT comes on the other side first. So I will rewrite this first. So d 2 dVOT upon dt plus VOT is equal to 1 minus dVAT. This on the other side. And now I put this. Is it okay? So 2 dVOT upon dt plus VOT is equal to 1 minus entire. Right? That is 1 minus d2 VOT upon dt square minus is it right? So both of these terms comes on the left hand side. This comes as plus, this comes as plus. So the final answer is
D2 VOT by
d2
dt square.
VOT upon dt square plus, now you got a change, it's minus plus 3 dVOT by dt
Plus VOT equal to
plus VOT. So it is a second order differential equation in terms of VOT. So double derivative of VOT plus triple the derivative of VOT plus VOT, their summation is constant. What should be VOT now? How will you think over it? You can use either the knowledge of differential equation solution. If not, then you can use common sense. What will happen? So you think for a while, we put pause for the video, and then when we start again, we start the video.